Hi, everybody. Thank you for joining us again here for another episode of Environmental Science. So we're going to start today off here with a little bit of a poll. I'm going to open that up. And I want to know, how big is the city that you live in? And I know some people were having trouble maybe locating the polls. It's right below the chat. So on the right-hand side of your screen, right under the chat, there's going to be an option to take a poll. And it's kind of a smaller button. So take a second to locate that and join our poll. How big is the city you live in? Is it less than 5,000? Is it between 5,000 and 60,000? So like still a small city, but not tiny. The first one is considered pretty tiny, like a town. 60,000 to 500,000. And then the last one is 500,000 to 1,000,000 plus. And if you're like, man, I have no idea how big the city I live in is. So I live in Bozeman, Montana, and we're going to be in that second column between 5,000 and 60,000. So it's a pretty small city comparatively. If you look at like Los Angeles is almost 4 million people in LA. So if you live in like a large city like that, like Los Angeles, San Francisco, New York, Atlanta, those ones are all going to be that last column. So take a second and vote on that. I'm going to go ahead and share my screen while we get started here. All right. And the reason that I am asking how big the city is that you live in is because that is really kind of directly related to your exposure to different atmospheric pollutions. And it's just kind of a fancy way of saying air pollution. But yeah, the size of the city you live in really directly impacts that and what you might be exposed to whenever you have a lot of people living together. Then that does lead to a high potential to be exposed to different kind of pollutants. Let's make sure our chat is up and running here today. If you are here, go ahead and say hi in the chat. And as always, our TA is here to help answer any questions that you might have that come up. If it's something that you want to ask right away, go ahead and put that in the chat. And then I'm also going to go ahead and open the Q&A. How that works is you can pose a question that you have. You might want to say like, hey, can you explain that again? I'm not quite sure, maybe I'll say, can you explain how smog is formed again? I'm not quite sure I got it. And then someone else can upvote it. So they can say, I have the same question. I'm still not quite getting it. And then Miriam can cover that in Discord at the end of our stream. She can go over those things again. And again, that's our TA. And so she'll be able to go over those things in depth again. So feel free to post that. All right, we are going to go ahead and just publish our results here, and then we will begin. All right, so we are 50-50 here in those kind of middle ground size cities. So that's awesome. And again, the larger the city you live in, the higher potential you have to be exposed to these different toxins. So the smaller the city, the more chance that it would dissipate, and you would have less exposure to those. So let's jump right in and see exactly what we're talking about. Let's hide this poll. And as always, just so you know, if you do say something in the chat, we can see your username. So if you don't want us to know your real name, you can hide it, use a fake name. And please do follow us on all of our social media platforms. Just like Miriam became a TA for us, that's something that you can do as well once you pass your AP exams. And you can come back and join us for a bunch of different opportunities like internships, becoming a TA. Maybe you could even work for us too. So definitely keep following us even after your AP journey to see how we can help you and different things that you can do to help us. Again, that Q&A, we're going to go over those in Discord after the stream. And if you haven't followed us on Discord yet, please do. It is really cool. Let's go back to that for just a second. That's how you find Discord. Discord is an awesome opportunity. It's kind of, I guess, like a chat room where you can be placed in a group of students who are also studying for the exact same exams as you. So you can go over questions together. If you have a question you're stuck on while you're working on your homework or something, you can ask for help there. And other students will respond to you as well as RTA. Our final upcoming streams here, we only have 2 more content streams to go. And then we're going to start kind of switching gears to go into test prep after that. And as always, trivia is the day after the stream. So we have trivia tomorrow at 7 p.m. East Coast time. And please go on and check that out. Trivia is like a multiple choice practice quiz for you, so you can see how well you got all the information I'm going to go over today and identify maybe areas that you need to go back and study again. And this is what we are going to go over today. We are talking about air pollution or atmospheric pollution and how those things kind of come about and what we have done to reduce them. So jumping right into it, the introduction of air pollution. Air pollution forms when burning any sort of a fuel source. So when we are burning things for fuel, byproducts are created due to impurities in the fuel, and these byproducts create air that can be hazardous to breathe. Byproduct, again, is something that is created on accident in the process of doing something else. So byproduct is just a substance that is made when burning stuff. In this case, it's a substance that's made when burning stuff that was made accidentally. And so there's no use for it. And sometimes it can be dangerous. When talking about air pollutants, there's 2 ways to categorize them, 2 ways to think about them. There's primary air pollutants and secondary air pollutants. Primary air pollutants mean that they're made from the source the way that they are. So they aren't going to react. They might react into something else, but as they are, is how they come out is the one that we're addressing. So carbon monoxide, nitrogen dioxide, sulfur dioxide, different particulate matters, and lead are all going to be considered primary air pollutants. Particulate matter is like when you're burning something, there's little tiny pieces of ash, and sometimes they're so small you can't even see them. And those little tiny particulates are in the air, and you can breathe them in. And a lot of times the particulate matters are actually some of the most dangerous parts of air pollution, especially when it's talking about burning things. Those little particulates can, think back to biology and what your lungs look like on the inside. They look like little trees. Your bronchioles on the inside. So sometimes your bronchioles can actually get clogged with different little particulate matters if there's like smoke in the air. And that can be really dangerous because your lungs kind of swell up around them in an attempt to isolate it or because they're irritated. And that can cause lung cancer. So that can also cause things like asthma or just coughing, trouble breathing. So particulates in the air can be just as dangerous as any of the chemicals. And then a secondary air pollutant. Secondary means that it's going to form out of those primary air pollutants, either 2 primary air pollutants interacting with each other, or a primary air pollutant interacting with gases that were already in the atmosphere. So tropospheric ozone is an example of a secondary air pollutant. And let's break that down a little bit. Remember when we talked about the layers of the atmosphere, and I said that there were really only 2 that you have to know about for this class. So the troposphere was the layer closest to the Earth, and it's basically anywhere that's going to have the gases that we interact with. For the most part, it's where like all the oxygen is. I think about like even an airplane flying like super high up in the air. What is it? 32,000 feet is where airplanes typically fly. And that's still the troposphere. So like any airplane is still going to be in the troposphere. The very tallest mountains, all of the clouds, all weather occurs in the troposphere. So when we talk about tropospheric ozone, that means any ozone, the chemical ozone, which is O3, any ozone that occurs in the troposphere. And that's because there's also ozone that's in the stratosphere, which is the next layer up, which is much higher. We don't fly there. It's kind of starting to be like space when you think about going away from the Earth. So hopefully that kind of breaks it down again. Tropospheric ozone is ozone that's going to be down here, kind of where we are. All right, and that brings us to smog. That's our first type of real air pollution we're going to talk about. Photochemical smog, which is just kind of the fancy way to say smog. There's not like different kinds. Photochemical smog is created by cars and sunlight. So that is the very easiest, simplest way to understand what is going on with smog and where it's going to occur. So in your head, you've got to just get that stuck in there right now. Photochemical smog, or smog, is going to be created by cars and sunlight. And then from that, you can, if you can remember that, you can kind of break it down to like what is creating it, you know? So cities with warm temperatures and a lot of cars have a much higher rate of smog formation. So think of cities, if you can, that have a ton of cars, and so like a lot of people and high temperatures, and that is going to lead to the creation of smog. So a city like Los Angeles is a perfect area for some smog creation. Again, at hot places, so like Atlanta, Mexico City, different places like that are going to be more susceptible to smog. And again, we'll kind of talk about two places that have mountains around them to trap the smog in are going to have an even higher occurrence of smog. So again, Los Angeles is trapped by mountains. Mexico City is trapped by mountains. Different cities in China are trapped by mountains. And so they have really high amounts of smog. And if you are from a small town, you may have never really seen smog and what it looks like. And the word smog is kind of like a smoky fog. So it can be so thick that it is hard to see through, just like a foggy day. But that's very rare, especially in the US, that would be rare. But in that picture there, if you look in the mountains on the background, you can see that they're kind of covered with a haze, like a brown haze. That is smog. So it is kind of just like a thick, almost looks like smoke, but it's not. It's definitely made with by something else. So let's look at that. Photochemical, and that if you break that down, photo means light and obviously chemicals. So light and chemicals mixing together creates that smog or that smoky fog. Is created when nitrogen oxides and volatile organic hydrocarbons react with heat and sunlight. So nitrogen dioxide is the primary pollutant. It's generated in the combustion of fossil fuels. So let's break that down a little bit. Combustion of fossil fuels. Fossil fuels are going to be things like coal and oil and natural gas. So this is where we are talking about like a lot of cars. So nitrogen dioxide is generated primarily from vehicles burning gas. So that's why whenever we have a city with a lot of cars, that you're going to have more smog. So nitrogen dioxide here being generated from a lot of cars exhaust. And what happens is nitric oxide is formed first and oxidized to form nitrogen dioxide. And when we are referencing both together, it's written as NOx. So when you're talking about NO and NO2 together, then we use the symbol NOx, meaning both of those. And then in addition, tropospheric ozone, which is a secondary pollutant, is created in the same reaction. So it's generated by sunlight interacting with nitrogen oxides, NOx, and hydrocarbons. And that's a major component of smog. So let me break this down just a little bit, because I know that that's a lot of large chemical words and it sounds a little bit overwhelming. But in general, we put gas in our cars and we drive around. And driving around is caused by the combustion or burning of that fuel. And when that fuel burns, it generates a lot of energy and has the car move. But it also creates the byproduct of those nitric oxide and nitrogen dioxide, which then react with hydrocarbons found naturally in the air. And that creates ozone, or tropospheric ozone, meaning ozone that's down in the lower levels of the atmosphere. And that ozone is a major component of smog. So that's kind of how we can break that down a little bit. Another note, which we'll go over more in Unit 9, ozone is actually has a very high thermal retention property too, so it can hold on to heat really well. And that kind of leads to climate change, specifically in cities or places that have a lot of smog or a lot of cars, and then just climate change in general. So wherever that ozone does exist, it does trap heat in addition. Ozone can be cancerous when it's breathed in. So ozone can be dangerous to human health as far as breathing it and breathing in that smog. This I found absolutely fascinating, and I wanted to ask you guys as well, especially I was curious if we had anyone who is living in a big city right now, if they've noticed this, if it's been visible. So what this crazy images with all these colors is air quality days. So this is Los Angeles, and as we look at air quality, they give it a rating, and I know it's really small in the bottom right there, but green would be good air quality, and then all the way up to that like purple color, which is hazardous air quality. And if you are not from like some cities that do this, if you live in like a smaller town or even a state that has like less population, you may not know this, but in large cities like this, definitely in California, they have days where they suggest you don't go outside because the air is so bad. It could be bad for your health. So they say like, don't go on a run outside today because it is one of those hazardous days. And then they actually like issue different things called like a spare the air day would be a day where they would say, please don't go outside and burn a bunch of stuff today because the air is already so bad it's hazardous to be outside. So we all need to be careful and try and spare the air today. So if you don't have to drive, please don't. Which is kind of crazy that that's just the norm there, that the air does get so bad that you have to try and tell everybody to like not go outside. So anyways, looking at this picture, you can see days that are like really bad and days that are better. And in the center there, you have a lot more purple days, and that's summer, right? Because think about what creates smog, right? Cars and sunlight. And you have a lot more sunlight and heat in the summer. So you definitely have those spare the air days in the summer, not really in the winter. And look at 2020 down there on the bottom. It has the largest span of good air days that's been recorded, since 1995. And it's like, well, why, right? Like, what's going on? It's the pandemic. And it's because so many people are not driving to work like they used to. Everybody's working from home, and it's made that big of an impact on the air quality in just this short amount of time. And so that's why I'm curious. I live in a smaller town, so you can't really see, there's not really smog here anyways. So I would just be curious for someone who is living in Los Angeles or in a larger city, if you've noticed any difference in the air quality. Please feel free to throw that in the chat if you have noticed that or any other thing, caused by the pandemic that's changing, the environment around us. It's really cool that that picture on the bottom shows the air quality in Los Angeles and how it's changed because of the pandemic. So it's actually visibly better that people are not driving as much because more people are working from home, which is really cool because then it's like, well, should we just change society in general? Should we all just work from home because then there's so much cleaner air? And what else could we do? How much cleaner would the air be if we all drove electric cars or something like that? So you can see that when humans change their behaviors and change what we're doing, it does have an actual substantial impact on the environment, and very quickly too. Like what if we just made a rule like overnight that no one can drive cars that burn fuel, right? Like what if overnight we all had to just have like electric cars? How's that going to change the air quality for us and change our quality of life really quickly? So it kind of makes you think like, well, why haven't we done that yet? Right? Like, why are we still living in a society where we pollute our air that we have to live in? sort of crazy. So not to get too distracted onto that topic, but it is really interesting how the pandemic has impacted the natural world as far as the air pollution. And I'd be curious if you've noticed any other impacts as well. Okay, so then there's that QR code for that website that talks about, that's like this article that I found, if you are curious on still looking at that and how else we've noticed the pandemic impacting environmental science and different things like that. That would be something fun to talk about in Discord as well, if you've noticed anything neat. I'm also curious, I wonder if there's an impact on trash, now that we're all ordering stuff from Amazon and everything's coming like in a box on its own instead of getting purchased from the store, if there's going to just be like massive amounts of cardboard waste or like we're going to need to cut down more trees because we're all switching to Amazon instead of, or at least ordering stuff instead of going to the store. Anyways, distracted, but it's such a cool topic. Okay, thermal inversions. This is what we were talking about a little bit about, that thermal retention property, which is just a fancy way of saying that it can hold in heat of different chemicals. So any deviation from the normal heat gradient in the atmosphere, a normal heat gradient is going to be like it's hot by Earth and then it gets colder as it moves up, right? So the sun heats up the land and then the air is warmest by Earth and it gets cooler as it moves out. So any deviation from that is what we're talking about here. And this occurs when a layer of warm air sits on top of a cooler layer of polluted air below it. So there's that picture of that person standing there. It's warm air, so that there'd be like warmer air where that person is. And then cold air is coming in underneath it and it's being kind of trapped. So you can see there, that's actually like a valley and there could be a city underneath it. And then those are clouds. So the person is kind of standing above those trapped clouds and trapped chemicals below them. And if you do live in Los Angeles and you know that it's surrounded by mountains, you can go up into those mountains and stand there and you can see this thermal inversion. So you can see the clouds trapped below you. And even if it's not a cloudy day, if the clouds aren't trapped below you, you can see the smog and you can literally see yourself above it. And then when you drive back down, you can see yourself descending down into the layer of smog and pollution. It's kind of crazy. The cooler polluted air is prevented from moving. It sits on top of that land or that city for an extended period of time. It gets trapped there basically until a storm comes through and has a lot of wind and pushes everything out and clears it out. So you can have, a week where this air is just trapped. Imagine a week-long time where all of the cars of 4 million people are driving around and putting that pollution there, and it's not moving. And I could look up the population of Mexico City. I do believe it's more than Los Angeles. So imagine all of those people in cars driving around, and the air, they're sitting in that air. So you're breathing in the pollution from the car that you drove around today, tomorrow as it is just sitting there. And it's much more common in cities with mountains around them that kind of create a bowl to hold the air in that pollution. So again, those geologic features really do impact the air quality as well. All right, and moving right along, indoor air pollutants. So we're going to talk a little bit about indoor air pollution and what that looks like and why it can be a little bit different than outdoor air pollution as far as impacting your health. So indoor air pollutants can be particularly harmful because we spend so much of our time indoors without fresh air, especially in colder climates now. So colder climates, you're more susceptible to indoor air pollution, like the harms that come from that. And then in the winter as well. So this is like kind of flip-flopped from the outdoor air pollutants being kind of worse in warmer cities and in the summer. And that's just because we have the windows closed, right? So if you have some sort of pollutant or toxin in your house and you're sitting here for days at a time with all the windows closed, then you're just breathing that same thing in over and over again. And here's just a list kind of to break down the major types of indoor air pollutants. On the exam, this is something that could be found on a FRQ, and they'd want to know like what is the type of indoor air pollutant and what is its source, and then like maybe what health effect does it cause. And a lot of the health effects are going to be like the same type of thing. So it's going to cause like cancer, headaches, or possibly asthma, breathing problems, eye irritation, allergies, that kind of stuff. And then obviously some of them are going to be different than others, but like in general, those are the typical symptoms from these different air pollutants, indoor air pollutants. And then knowing the source of the different ones is important too. So building materials. So your home that you're sitting in, we've all trusted the people who built our house or our office building. And we've trusted the people who generated these products to have made something that's not going to give us cancer or be bad for us, right? So we're trusting the people who made the paint, that it doesn't have toxic chemicals in it. We're trusting the people who made your carpet, that doesn't have toxic chemicals in it. The insulation in your house, you're trusting them. And a lot of the stuff we don't even think about, we just assume it's going to be fine, but it's not always fine. Sometimes we realize like, oh man, we made a huge mistake there, and that actually causes cancer, and we built your house out of it. Definitely something to think about. And our government does try and protect us as much as possible from what, it knows. But sometimes we think that something is a great product, and 20 years later we realize, oh shoot, actually that's extremely dangerous and it can cause cancer, so we probably shouldn't have used it. So that's kind of the problem, is that we don't know what we don't know. And obviously people or companies try to do the right thing, but sometimes mistakes are made. And particularly with like asbestos, that is one that is, asbestos is a substance that is very similar to like glass, and it comes in these little fibers, and it is really, really good at insulating. So if you put it in your walls, you're going to keep the hot or cold air out, and your house is going to be really regulated with temperature. But if you like touch the asbestos and breathe it in, it cuts the inside of your lungs up, and it causes like a specific lung cancer pretty regularly. So that one is very bad. We found that out, and it has to be removed from buildings under like extreme care. Same thing with lead. Lead-based paint was used, but if it gets scraped, you get lead out into the air. You can breathe in lead. The VOCs is volatile organic compounds. And then different particulates in your house. So that's different building materials. Just something to think about in your house. Different things could be maybe not great. And the VOCs are found mostly in like carpets or furniture. Sometimes we spray furniture and carpets with like a chemical that's going to keep it from catching on fire. Which would be great, right? Because we don't want our house to burn down. But then we didn't, maybe realize that chemical would give you chronic headaches or asthma or, lung cancer. Okay, and so some naturally occurring indoor air pollutants would be radon. So not everybody has to deal with radon in their house. It depends where you live. And it's naturally occurring. So it's either naturally occurring in the land that you live on or not, depending on like what state you're from. So you have to like look that up if you're interested to see if you have a potential of having radon poisoning or radon in your house. And what it is there's naturally occurring uranium in the soil. And as it decays, radon gas comes out of the soil. And if it was just like in the park across the street, it's going to go out into the air and dissipate. And it's not going to be like an amount that would be harmful for you to breathe, right? Because then the wind's going to move it away, and it's really fine. But if it's decaying in your basement underneath your house, that gas is going to come up through the floorboards of your house, and you're going to have it in your house, and there's no wind in your house. It's going to get stuck there. And then you're just breathing in that gas that can cause cancer. So that's not great. They do different things when you buy a new house. You have to get like a radon check, again, in certain areas. So in some areas, it's not a big deal. Like it doesn't happen there. So it's not a thing. But here in Montana, when we bought our house recently, they came in to the basement and set up a little machine for like 24 hours, and it detected the amount of radon to see if it's dangerous or not. And if you don't have a dangerous amount, again, it could be, my house has none, but my neighbor's house has a extremely dangerous amount, just because of how much uranium was under their house, right? So it could be like literally one house is fine, the next house has too much, just based on where it is in the soil. And if that does happen, then they just like put in fans to try and blow it out of the basement, to monitor the levels. So that's something interesting. Other naturally occurring issues, and again, you could have a question on radon on the test. So it is important to know, like, where does it come from? It's naturally occurring, and like what can be done to mediate it or remediate it would be to like monitor the levels and then have fans to blow that air out so that it's going away. You could also, I guess, try and like excavate or dig out the land previous to like remove it. But I think that I don't know if that's actually done, but that could be a possibility of how to do it. But for the most part, the house is already built, so fans and detection is important. Then we have dust and mold. Dust, some of us are allergic to dust, some are not, and it occurs in our house, whereas like outside, you don't really have like huge piles of dust, right? Because the wind is going to like blow it around, it's going to decompose, and in your house, you can gather that dust, so it's important to move that around. Mold, again, that is something that happens more based on where you live. If you live in the Southwest, mold is not really an issue because it's so hot and dry. But if you live in somewhere that is like humid, mold can definitely happen. And that's something that they would have to worry about in houses there. So definitely on the East Coast, it's going to be much more humid, or maybe in the Midwest, it's more humid in the summer for sure. And mold is like a naturally occurring organism that lives off of digesting the parts of your house when it gets wet. So that can, when it has spores, when it reproduces, those can get in your lungs. It can make you very, very sick. So if your house is somewhere where it's more humid, you have to make sure that it doesn't have mold. And then the last one, naturally occurring in a closed system, we've all been very familiar with lately, is bacteria and viruses, different infections. If you are living somewhere where you're in like a building with a lot of other people, maybe like an apartment, and you have a much higher chance of getting sick from someone coughing into that enclosed air system than you would if you were outside, right? Because if someone coughs outside, it's going to blow away. But so again, that is more dangerous inside. And then byproducts of combustion again. So these are things that are created accidentally when burning stuff. And in your house, you might be like, well, I don't ever burn anything in my house, but you do, because you heat your house, which is typically done from gas. You might have electric heat in your house, but typically it's gas. Your stove might be gas. Your dryer, where you dry your clothes even, might be gas. And again, those things can be electric, so it just depends on your house. So carbon monoxide is like a highly dangerous chemical from burning things, because you can't see it, you can't smell it, but it's an asphyxiant, meaning that it will cause you, like, you breathe it in instead of air, and you don't know you're breathing it in, so you could die. A lot of times carbon monoxide poisoning, people die in their sleep because you're just asphyxiating or suffocating, because you're breathing in this gas that you don't even realize it, so you wouldn't even wake up. So that can be very dangerous. And that's why you have carbon monoxide detectors in your house, or you should double check and make sure you have carbon monoxide detectors in your house. And fun fact about that, carbon monoxide is heavy, so it flows, or if it did get in your house, it would be flowing kind of on the floor as it went up. So your carbon monoxide detectors typically are plugged into the outlets on the floor, or like the outlets low in the room. You wouldn't want to plug a carbon monoxide detector like a smoke detector on the ceiling, because if you had so much carbon monoxide in your house that it was all the way up to the ceiling, you'd probably be a goner by that point. So again, carbon monoxide detectors are typically plugged in on the floor. So double check you've got those in your house. And then smoke as well. Smoke is a byproduct of fire. So that's that particulates in the air. And again, make sure you have your smoke detector set up to let you know if that is in your house. But you probably know if you have those because they probably go off when you're making breakfast or something. And they're very loud. Anyway, so that are other chemicals just from combustion or burning of things. And again, it doesn't have to be like, oh, we don't have a fireplace, so that's not a problem for us. Again, there's a lot of things in your house that are burning things that you might not even realize. Before we switch that, actually, so how do you reduce your exposure to these indoor air pollutants? And the obviously those kind of ways that we talked about reducing them. But in addition, opening the windows. If you can, if it's warm enough outside, open the windows as often as you can and air out your house. And that is going to be the best way really to get fresh air in there and reduce these pollutants. Something else, a term that you might run into on the test is called sick building syndrome. Sick building syndrome is when a building, a house, an office building, whatever, is causing the people to be in it to be sick because of one or more of these pollutants. And sometimes it's hard to identify what it is. Sometimes they can't figure it out. I remember, I want to say it was a school in California. I don't remember the name of it, but I'm not sure I should call them out. But the teachers all kept getting really, really sick, and they would have headaches, and they would get like really high numbers of teachers were getting cancer. And so that was kind of like it was a sick building, like something was going on in that building where everybody was getting sick and they didn't know why. And it's like, are the walls filled with mold? Is there radon poisoning coming up through the ground? Is the furnace flooding it with carbon monoxide all day long and people are getting sick because of that? Who knows, right? So that's definitely something that happens called sick building syndrome when being in a building or being indoors is causing the people who are there to get very, very sick because of it. And it would have to obviously investigate what's going on and figure that out. Okay, so without getting too much into this, let's keep moving here. All right, acid rain is the next concept we're going to go over. And acid rain, so oxides of sulfur and nitrogen react with water to form acids and fall back down to the earth as rain, snow, or hail. So acid rain doesn't have to be rain. It's really just like any form of water coming back down to the earth. And a higher level of acid. So what does that mean? Let's start there by looking at our pH scale again and remembering what is an acid. Increasing acidity would mean a smaller pH number. So definitely remember that. So neutral or water is going to be around 7. And then increasing acidity is going to drop us down into the lower numbers. And so when we burn coal, this acid rain typically, like we said before, smog is typically associated with cars. Acid rain is typically associated with the burning of coal, and we burn coal in power plants, so to generate electricity. So typically in coal burning areas, this is where you would see more acid deposition or acid rain issues. And that happens a lot on the East Coast of the US, more so on the East Coast of the US than on the West Coast is where our coal burning plants are going to be. But when we burn coal, it creates byproducts again here, and that's the nitric oxides or sulfur dioxides. Cars also generate nitric oxides. Remember, we talked about that too, but they're not as heavy as a contributor as the coal power plants. So it does happen around cities just with a lot of cars too, but again, not anywhere near as much as a coal burning power plant. Those chemicals combine with water in the atmosphere and it decreases the pH level of that water. So when you do have those chemicals combining with water, that pH level drops. And as it comes back down to earth in whatever form, that is going to be considered acid deposition or acid rain. The increasing acid in the environment can kill plants, it can erode rocks and kill aquatic organisms. And again, we're not talking about, like, this isn't like in crazy strong acid or anything. It's not like it's going to burn you while you're outside if you get some water on you or anything like that. But if things are sitting outside for an extremely long time, then they are going to, over time, show that burning or issues from it. So, like, again, trees, if you left a car outside for a really long time, you could see it kind of eroding the paint. Buildings, especially buildings made of like limestone, can be eroded as well. So how do we prevent this? What stops it? Less reliance on coal burning. We just need to stop burning coal for electricity. And in addition, so calcium can be added. So calcium is going to be like a base. You can add calcium to soils to reduce the effect on farms. So if you have a farm that is the soil acid is really high and plants can't live there anymore, you can add calcium carbonate to the soil in order to bring it closer back to neutral, to allow plants to live there again. So again, this isn't like this crazy, like, acid is falling from the sky kind of thing, but it is just like a long-term damage to plants and buildings and farms and things like that. So it does cause long-term damage. So again, when you think about acid rain or acid deposition, we want to think coal burning power plants, typically kind of on the east coast of the US, and long-term damage to natural ecosystems. Let's see, look at that picture again there. So you can see this forest would have been exposed to long-term acid deposition, and you can see it's burned the leaves off of all the trees and caused the trees to die. So that's kind of what a forest would look like that was near a coal burning power plant. All right, so what do we do to stop this? Man, we've talked about a lot of air pollution and how it's affected us, especially in our cities. Once identified, humans have made great steps to reduce the levels of different atmospheric pollutants. And here are a few. Okay, so methods to reduce air pollutants include, the three main ways are regulatory practices. So we need laws to stop the production of these chemicals, conservation practices, or alternative fuels. So regulatory practices, laws, and acts, here are a few important ones that you will need to know. The Clean Air Act set emission standards for cars and limits the release of pollutants. So the Clean Air Act is going to set emission standards for cars. So cars can't like just be giant polluters anymore. And some cars are like grandfathered in, right? So if you have like a super old collector car, it doesn't have to follow these rules, but new cars do. And then you may know you have to get your car checked. It's called a smog check. And you have to get it checked, I think it's every 2 years, depends on the state you're in. And they hook it up to a machine and they run it at like different, 30 miles an hour and 15 miles an hour. And they say it creates so many pollutants or it doesn't. So it either passes or doesn't pass. And if it doesn't pass, you can't drive it. You can't register it. So that's one way of taking cars that pollute too much off the roadways and reducing the overall pollution in a city. And the next one, the Kyoto Protocol. This sets greenhouse gas emissions and reduction standards. So again, remember we talked about the tragedy of the commons. Whenever different countries are working together to protect a commons, and the air is absolutely a commons that we use, the countries can choose to join it or not to. And the Kyoto Protocol was not highly successful because not a lot of countries joined it. I believe the US and China did not join or joined like conditionally, like, oh, we'll do some of the things, but not all of them. And so it was really not very successful in reducing climate change and greenhouse gas emissions overall. And the reason that some states didn't join it is kind of, again, that goes back to that commons, like everyone has to agree in order to reduce climate change so that we're going to like massively change our economy, right? So instead of relying on fossil fuels, we're going to switch to wind and electric power and electric cars, and we're going to make this like huge change. And it might be expensive at first to make that change, and people have to learn new technologies and stuff. And so if a country says like, hey, I don't want to do it if they're not doing it, because then we're going to to suffer that initial change is going to be difficult. And if they're not doing it, we're not going to do it. And that's kind of what happened. And so not everyone joined, and they said, it's not fair if we have to do it and they're not going to do it. Really, that's kind of what was said. And then the Montreal Protocol, I know we didn't really talk about CFCs too much yet. We're going to talk about that in like Unit 9. But the Montreal Protocol talked about the depletion of the ozone. And I heard this comedian kind of making fun of environmental scientists say like, oh, everyone was all worried about the ozone. And then, you don't hear anyone talking about that anymore. Like, what, we forgot about it or something. And it's like that the joke's on him because it's not really an issue anymore. And that's because the Montreal Protocol was widely joined. A lot of countries were like, yep, that's a good thing. Let's all do it. And phased out CFCs, and it was highly effective. And now the hole in the ozone is a much smaller deal than it used to be because countries and people made a change and made it happen. And so that's an example of it really working out well. So conservation practices just means using less energy that generates pollutants, right? So pollutants are, again, all byproducts of burning stuff and fuel. So can we all switch to electric cars? Can we all stop driving to work? And those are ways that it's going to conserve fuel and conserve our pollutants that we are going to put in the air. Same thing with alternative fuels. If we can switch to clean energy, then we will be making less air pollutants. So if we can have all cars be electric, then smog would be, non-existent or much, much smaller of an issue. And here are some regulation practices for cars. So again, you're going to need to know these ones specifically because this could be an FRQ question where they say, what was one regulation practice that was generated to reduce air pollution, or what was something for cars that an invention for cars that reduces air pollution and how. And so again, these are those like two things. So what was it and how does it work? Vapor recovery nozzle, that's that picture there. So before you would just like fuel your car, and as the liquid fuel is coming in, gas like air is coming out. And so see how it just has that like rubber circle? That rubber circle is going to prevent those fumes from coming out, and it's going to redirect it back into the tube and up through like the hose for getting gas, and it's going to store it. So it's going to prevent it from leaking out into the air, and it's going to keep it contained. So that's a vapor recovery nozzle. Simple invention that is making a difference. The next one is a catalytic converter. Air pollution control device for internal combustion engines, again, on cars. So cars have to have a catalytic converter. And that is what, like when you go get your smog check, they're checking your catalytic converter. Is it working? And is it reducing those harmful pollutants into less harmful pollutants? So there, again, it converts carbon monoxide and nitrous oxides and hydrocarbons into CO2, N2, O2, and H2O. And then the last one, we talked about this before, corporate average fuel economy standards, CAFE standards, is the overall increase in fuel efficiency for cars. So we had to say basically, Ford has to have 35 mile per gallon average among all of its cars. So you can still have big SUVs that only get 12 miles to the gallon, but you also have to offer an electric car then as well, or a compact car that gets 45 miles to the gallon, as long as your average is 35. And that number really, it was 25 for a long time and then 35, but companies are kind of on their own saying they're going to up it to 50, or they're going to go completely electric kind of on their own without even the government pushing that. All right, and then our last one here. So this technically is in the atmosphere, noise pollution. It does seem kind of weird because it's not really like an air pollution. And as far as like where it appears in the course, organization, it's kind of doesn't seem like it fits here, I guess, but we will go over it anyways. So noise pollution is just that. It's any unwanted or disturbing sound that interferes with or diminishes the quality of life for animals or humans. And again, if you did vote that you live in a big city, you are much more familiar with noise pollution than us living in our smaller towns. You might have to deal with sirens going by constantly, or people outside yelling, or car alarms, different things happening all the time. And you probably, if you live there, you just get used to it and you don't even hear it anymore. It's always kind of crazy to go from one type of city to another. If you go visit a big city, you might not be able to sleep all night because you're like, what in the world? It's so loud here. I remember going to stay with my friend one time in Chicago, and I woke up in the middle of the night, like terrified. And it turned out, I didn't realize, but her apartment was right next to the train tracks of the transport trains that they have there. And it was terrifying. And she like doesn't even notice it. She just sleeps right through it. Same thing. If you go visit someone in the country, you'll be like, I can't sleep because it's so quiet. You have to put like a fan or something up because it's just absolutely silent at night. Okay, so these are different sources of different noise pollutions and how it would affect animals or kind of the natural world. So wind farms are really loud. So that is one of the negatives of living next to a wind farm. Sonar is what like military boats use to detect other military boats, or to graph out like the bottom of the ocean, or to detect if there's a submarine coming, or even a submarine would have to use sonar. Sonar is just like when you make a very loud sound and then you listen for it coming back, and how it is detected when it comes back. You can see a picture. It's the same thing that dolphins use. So dolphins use sonar. It's called like echolocation for them. It's the same idea, right? So when a boat is out there and makes like a giant sonar sound, that really affects animals that use sonar for their navigation or their ability to see. So we're not 100% sure why a bunch of whales or dolphins beach themselves like this. There are some different theories. One of the theories is that whales can sort of get like the bends just like humans can if they come up too fast, or so a lot of times when they do beach themselves like this, it's after a boat was out doing like really loud sonar. And when they did necropsies or autopsies on the dolphins, they found that they did have bleeding in their ear canal. Dolphins have ears, it just has skin over the top of it. So it'd be like if your ears like just had skin closing it, but they do have like ears underneath there. So in their ear canal, there was like blood. And is it because the sound was so loud that it exploded their ears? And then they were disoriented and they didn't know how to swim anymore because they use like their ears to see with echolocation? Or did they get so scared that they surfaced so fast that it kind of blew out their ears? We don't know, but there definitely is a correlation between using like large amounts of sonar and scaring the dolphins to the point where they kind of all beach themselves on land. Airports are extremely loud. If you live near an airport, or if you're an animal living near an airport, that could interfere with your life. If you're a bird and you need to be able to communicate, you won't be able to hear. Construction zones, extremely loud. So again, that's going to impact cars. That's going to impact animals and their ability to live in that natural ecosystem, as well as humans and your quality of life. If you live in a place that's extremely loud and you can't sleep, that's going to be stressful. It might cause you to have stress-related illnesses like high blood pressure. That's definitely more related or higher occurrences in cities than it would be out in the country. And again, environmental consequences of that is going to be, it's like some animals, they just like don't like noise. So they're going to not want to live there. Maybe they will adjust their behavior to living at night. And you see that sometimes. You see a lot more animals come out at night in a city than during the day, or maybe they'll just leave altogether and go to someplace different. Or again, fear response and strandings in marine mammals as well. Whew, all right. Okay, we did it. All done with Unit 7 and our air pollution. This is Unit 8. So it does look a little bit stressful. It's another one of those huge units with a ton of concepts. And we are going to hit all of these. We're going to do it as fast as we can as far as just the major, what do you need to know for each of these ideas. But I want to know, I was still working on those slides, so I want to know which ones you found. Let's open this one. Which one of those things give you the most, oh shoot, my question's a little bit worded weird there, sorry. Which one of these is giving you the most anxiety? Is it eutrophication, bioaccumulation, and biomagnification, or solid waste disposal? Sorry, it says solid waste disposal in the question itself too. So of those three, which one is currently giving you the most anxiety? And I will make sure to cover that more in depth next time. All right, here are our results. Let's go ahead and publish this. All right, I am happy to see that you feel comfortable with eutrophication because we have talked about that a few times already. So I'm happy that you feel like pretty solid with that. But we will talk about solid waste disposal and bioaccumulation and how that happens next time for sure. So hide this thing here. Thank you so much for joining me today. I hope that you have an awesome rest of your weekend and that you get to eat some candy and hang out with your family a little bit. Please head over to Discord now and let us know if there are any questions that you have or anything that has come up that you want to know more about, anything that you want to share with other fellow students about these topics, good resources that you may have, things like that. So again, if you have any questions or have something that you want me to cover more specifically next time, mention that in Discord and we will get to it. All right, everybody, thank you so much for joining us and I will see you again next time.